Hi, welcome to Parametric House. In this Grasshopper tutorial, I want to show you how you can produce a series of random lines inside a boundary. It can be any polyline or a curve. And we're going to use the Anemone plugin to define a repeating pattern. So if it's 0, we can make those lines by using a random distribution or by defining 2 degrees, for example. So if I use that, you can see that this is going to control the initial degree, and when I increase the repeating pattern, it's going to jump to this second number. So if I just increase that, you can see that I can control the second number, and then because it's a repeating pattern, it's going to jump again to the first degree. So here you can see that it's a really interesting pattern for splitting the surface using the surface split component. We can also use a randomize component to produce random distribution of rotating lines and cutting lines, and also coloring it, which will be at the end of this tutorial. Okay, let's get started from scratch. Before I teach you the Anemone technique which we're going to use here, I'm going to use a simple component just to get you started. So if you go to the mesh menu and in the triangulation, we have a substrate component. Here you can see that you have the substrate component, and this is just like for the beginning of the tutorial, so you understand how you have a really simple component inside Grasshopper but with some limitations. So the first input is a border, which is going to be a rectangle. As you can see here, this input indicates that it's going to only be a rectangle. What I want to do here is to draw a rectangle, for example. If you right click here and set it, you can see it's going to ask you for a rectangle. So you can draw it, but it's not going to be parametric, because if I change it, it doesn't change the output. So I can go to the params menu, geometry, and use a curve and set this to the rectangle. So it's going to be parametric and it's going to update the results. Another input is the count. So for example, if I say from 1 to 100 and give this to the count, you can see it's going to start with 1 line, and when we increase it, it's going to increase those lines. There is another input, which is the angles, but as you can see here, this angle input is based on radians. So in radians, if I want to make it as simple as possible, make it in degrees, you can search for RAD, which is in radians, and I'm going to give that to the angles. Okay, now that we have that, we can give it a degree. So for example, if I only give it a 1 number slider, this is going to be the degree of the division, which is something I think randomly. So here you can see that it's going to just randomly change the distribution and rotate it 90 degrees. So this is also possible. But what if we want to give a series of degrees? We can do that by going to the params menu, utility, and let's use this gene pool. Double click it. We can say we need 4 different degrees from 0 to 360 degrees. Okay, so that is going to give us 4 options. If you right click here, you can randomize it. So you can see that we have 4 random degrees, or you can just stick with numbers you want. The problem with this gene pool is that you can't double click and select it. So if you want to select, what you can do here is to define a number slider between 0 and 360 degrees, and just use Ctrl+C, Ctrl+V to copy paste it, and use the Shift key to add it here. We can say we want a 0 at 30 degrees and maybe 70 degrees. Okay, so these are going to control the output. Another thing we can control here is the deviation, which is a number in radians again. So if I just say radians, give it to here, and start from 0 to 90 degrees, this is going to change the output again, but it's going to just, as you can see here, it's going to also rotate those lines. So for example, if I have 0 and 90 degrees, I think this is going to be a good example. If I put it to 0, it's completely 0 and 90s. But what if we just give this a little bit of deviation? So here you can see that this is the maximum deviation you can give that. And maybe you can say it's going to be 10. Okay, so that is also controllable about this one. A seed is an engine. Just give it any number slider you want, and it's going to give you unique outputs. So if I just change that, you can see it's going to produce random results. Anyway, after producing the random lines using this substrate component, it's only going to give you the lines. So if I bake it, you can see it's only going to give the lines as an output. So what I want to do is to actually split the rectangle with it, and it's only going to get a rectangle. So what I have to do is go to intersection, physical, and surface split. I give it to the surface I want to split and split it with these lines. Now you can see that it's going to produce a series of fragments, and it's really useful if you want to just have those surfaces. Okay, for the last part, what I want to do is to just make the random color, display, custom preview, give that to the geometry. For the color, what I prefer to use here, you can use a random engine here, but I found this plugin really useful. You can go to the Fennec plugin, display, and use this random colors. You have to define how many colors you want, so we can just go to the sets, list length, and count. We have, for example, 5, and then we can give it another number slider, which is going to be the seed or engine of this random color, and we can produce random colors. Okay, if I go to the rendered mode, you can see it here, and this is going to produce those random colors. Okay, that's it. So for the substrate, we have to just change these counts, the degrees we want, deviation if you want to control that, and randomize. Okay, so that is the whole algorithm, which we have produced a series of random lines inside a rectangle using the substrate components. I hope it was useful. Now we're going to use the Anemone plugin, go into a little bit more advanced, use any polyline, use any curve to get the outputs, and let's get started from scratch.